Hey guys, welcome to the next part of the holiday homework. Extending on section B, which looked at simple interest, we're now looking at modeling compound interest using recursion relations and rules. And we're going through the structure of them and the key differences. All right, so modeling compound interest with recurrence relations. We'll do this through a number of examples. An investment of $9,000, I'm going to highlight that because that's key, and it's compounding interest at the rate of 5.3% per annum. A recurrence relation that can be used to model the value of the investment after n years is shown below. So here's that initial that we identified up here. Our R value here, 1.053, was calculated using the rate up here. Now in a further example, we'll be going through how to calculate that R value, but that's where that has come from, that rate per annum up there. In the recurrence relation, Vn is the value of the investment after n years. So part A, use the recurrence relation to find the value of the investment after 1, 2, and 3 years. All right, so because we're using V to represent this recursion relation, what we're going to be doing is V1 for year 1, we're going to be calculating V2 for year 2, and we're going to be calculating V3 for year 3. Now, we need to follow the structure of this recurrence relation. This is saying 1.053 times the previous term to calculate the next. So V1 will be calculated by 1.053 times the previous term, which is the initial of 9,000. All right, type that into your CAS, and what you will get is the result of 9,477. Now we can use that result to calculate V2, 1.053 times the previous term of 9,477 gives us a result of $9,979.28. That's our V2. V3, same thing, 1.053 times the previous term of 9,979.28 gives us a result of $10,508.18. And that's how we would set that out. Part B, how many years does it take for the value of the investment to first exceed $12,000? Well, we already know what the value was for V1, 2, and 3, so now we can continue that pattern and keep going until we exceed $12,000. So V4, all right, you should know how to do the structure of the working out, 1.053 times the previous term. In the interest of saving time, I'm going to write the answers. So V4, you type that into your CAS, you get $11,065.12. V5, 1.053 times the previous term, that will give you $11,651.57. And then finally, V6, same structure, you get $12,269.10. Now we've exceeded $12,000, therefore the investment will take 6 years because it was V6 that was the first term over $12,000. And finally C, write down a recurrence relation model for the value of an investment of $7,000 at a compounding interest rate of 4.9% per annum. All right, so first thing, identify the starting or the initial. In this case, it's 7,000. When we structure our recurrence relation, it's going to look like this. We have the R value times Vn. So right now we need to work out what that R value is. The way in which we do that is R equals 1 plus whatever the rate is over 100. Now it's 100 because this is an annual rate, because it's compounding annually. If, for example, we were compounding monthly, we would need to adjust this by dividing by 12 or having the denominator of 1200. Now, in this case, our rate is 4.9. So 1 plus 4.9 over 100, which gives us 1.049. So putting the whole thing together in our final relation, we have an initial of 7,000, comma, Vn plus 1 equals 1.049 VN. All right, now that we've looked at recurrence relations, it's time to look at rules. Now, the way in which we'll do this is we'll firstly look at a recurrence relation and answer some questions, and then we're going to convert it into a rule. The value of a loan charged compound interest every year, the value of a loan charged compound interest every year is modeled using the recurrence relation V0 equals 3,000, Vn plus 1 equals 1.08 Vn. First question is how much money was borrowed? Well, that's just the initial amount, so therefore $3,000. What is the annual interest rate for this loan? We looked at that in the previous part. This gives away our rate here, therefore it is 8%. Now finally, part C, write down a value for the loan after n years. All right, so this is where we're going to take the recurrence relation and convert it into a rule. The general structure of the rule is going to be like this: Vn equals V0 times R to the power of n. So that's the key difference there. That is our rule. That's the structure of our recurrence relation. The benefit of having a rule is we can calculate future terms without having to calculate the successive terms in a row. So with the recurrence relation, we calculated V1, V2, V3. With the rule, what we can do is skip ahead and calculate, say, V8, for example, straight away. Now, in this case, V0 is 3,000 and R is 1.08. So we already have the information there. We're just changing the structure. And therefore, that's our rule based off this information. Now that we have the rule, we can answer a couple of questions on it. Use the rule to find the value of the loan after 4 years. So what we want to calculate here is V4. So we don't have to calculate 1, 2, 3. We can skip ahead simply by using the rule that we established. So 3,000 times 1.08, whoops, to the power of 4. We type that into our CAS. What we get is $4,081.47. And that's our answer. If the loan is fully repaid after 5 years, what is the total interest paid? All right, so first thing we need to do is work out how much we've paid after those 5 years. So again, same calculation. 3,000 times 1.08 to the power of 5 gives us $4,407.98. Now that's the total amount paid. We want just the interest. So to calculate the interest, what we do is we take this final amount that we just calculated here and we subtract the principal or the original. Our final amount was $4,407.98. Our principal was $3,000. Therefore, the interest that we had to pay was $1,407.98. Good luck with the questions in this section of the holiday homework. Hope you're all enjoying your break. Thanks, guys.